The lightning talk sessions are only featuring 10 of the projects. These are the ones that were the last few years rather than the early years of our center funding. So we don't have everybody represented here, but at least half of them, about half of them are. There is a web page that's gives you more information about this event, and the link is posted here. Molly, if you don't mind putting that link in the chat, that might be helpful for folks so they can click on it. And there you can find, of course, the names and the titles of the talks, but also the slides. And after the talk is finished, we will post a video recording of this session there as well. So I encourage you to look at that page. And you can visit our T-Course site in general, which has a lot of different information about our center, including the research that we produced and the different cores and projects within our center. So we have 3 sessions devoted to pilot project lightning talks. Today is the first session on tobacco use among youth. Tomorrow we'll have a second session on tobacco use transitions. And the third session will also be tomorrow on tobacco-related disparities. So I encourage you all to attend each of these sessions. I think they'll be exciting, and new research will be presented from the folks who were awarded the pilot funding. Just some logistics about today. Each presenter will have 5 to 10 minutes to give their talk. As I mentioned, slides or e-poster. Some of them may have chosen to do an e-poster, will be available or are available on our event webpage that is in the chat. You're encouraged to ask questions to the speakers. You can submit the questions at any time in the chat, but we'll use the Q&A portion of the event to address the question. So we won't be addressing questions during each person's talk. And you can also ask questions during the Q&A section by chatting or by raising your hand, and we'll call upon you. We will send you all an evaluation form after the conclusion of this event, the entire event, meaning tomorrow afternoon. And I ask that you please fill that out because it helps us track our accomplishments and the quality of our events. So we have 4 talks today, and I'll go through presenting each speaker right before their talk. So the first talk will be Dr. Alex Liber, and he'll be talking about the effects of tobacco 21 adoption on cigarette sales in the United States. Just to give you a little bit of background on Dr. Liber, give me just a moment. Yeah, so Alex Liber, he's an assistant professor in the Department of Oncology at the Georgetown University School of Medicine. Dr. Liber focuses his work at the intersection between markets, public policy, and public health. He received his PhD from the University of Michigan, Ann Arbor in 2020 in the Health Services Organization and Policy Program with a focus on political science. Since 2008, Dr. Liber has contributed to the field of tobacco control policy research, first at Ohio State University during his bachelor's degree, then at Emory University during his master's degree, and then at American Cancer Society as part of the Economic and Health Research Program. He uses quantitative and qualitative methods to answer pressing questions about the cause and effects of regulations, particularly in the area of tobacco control and novel tobacco products. So with that, I ask that Dr. Liber begin his talk when he's ready, and then we'll just go one by one subsequently and then begin our Q&A session.
Happy to do so. Well, thanks, Ritesh, for that very kind introduction. So this talk is going to be as lightning in character as possible. So today I'm going to talk about my Castor pilot project from 2021, which is still in process of getting written all the way up and getting all full results handled. The project looks at the effect of tobacco 21 laws on sales of cigars. So tobacco 21 laws are those policies that raise the minimum age of sale of tobacco products up to age 21 from a lower age beforehand, either 18 or 19, usually in the United States. And they, in the 2010s, swept across the nation until there was a federal Tobacco 21 law passed in December of 2019. I did previous work looking at the effect of Tobacco 21 sales, Tobacco 21 on sales of cigarettes. And I found certain brands of cigarettes that young people consumed that were evidently affected by Tobacco 21's passage at the city level that contrasted with certain kinds of cigarettes that young people did not use, which were not affected by Tobacco 21's passage. And essentially what I'm doing here is I'm repeating the process with cigars with a deeper attention to state policy detail and hopefully a little more advanced econometrics that are still in the mix. So I want to thank Mohammed Jaffrey, David Levy, Chris Cadam, and Michael Pesco for their co-authorship efforts on this project to date. And this work is funded by the same grant that powers University of Michigan and Georgetown's T-Cores. So the basic plan of this project was to identify those cigars that young people smoked. So the ones who were going to be affected by Tobacco 21 law, what kinds of products were they smoking? And then I would then combine that with information about where Tobacco 21 laws were put in place, as well as some of the details within them. And this mostly means whether Tobacco 21 laws just raised the minimum age of sale, or did they ban the purchase, use, or possession of tobacco products? This information was collected from a variety of sources, but right now I'm just going to talk about state Tobacco 21 laws in this project for the moment and sort of put aside the national Tobacco 21 law for later. And the ultimate effort is to, once we know which cigars young people smoke and where Tobacco 21 laws are in place, is did Tobacco 21 laws decrease the sale of cigars in the United States? So in order to do that, I'm estimating under 21 consumption shares, meaning like what proportion of a certain kind of cigar in a certain state and time were consumed, do we estimate were consumed by young people? And then using differences, econometric techniques, we're going to look at the effect of Tobacco 21 on format level. So this means splitting the cigar market into cigarillos, traditional cigars, and filtered cigars, which I really should have actually had a picture of this, but we'll gloss over that for the moment. And we're going to look at the effect of Tobacco 21 on each of these different categories of cigars. And so what we've had to do is we use the path survey to estimate for every brand and format what share of those cigars were consumed by young people. So this meant for the Backwoods Cigarillo brand, we actually estimated using Path that over a third of those cigarillos using estimated daily consumption, survey weights, and estimated number of days consumed in the last month, that over a third of Backwoods cigarillos were consumed by young people. That was by far the highest. But generally what we found within these splits is that cigarillos had higher consumption shares than either filtered cigars or traditional cigars. And filtered cigars had lower typically than traditional cigars. We also did this same sort of examination, but looking at the different flavors of cigars that people they consumed crossed by the formats as well. So here we see that, again, cigarillos have higher consumption shares than traditional cigars or filtered cigars. We see that menthol is probably lower than some of the other flavors, and that fruit and chocolate and clove are a little bit higher. But using this information and using sales data procured from the Nielsen Company, covering the period of March 2017 to November 2021 across 19 states where they have both convenience stores and what are called XAOC, or all other convenience, like pharmacy, food stores included. This is a representation of the distribution of the percentage of units that were consumed by under 21s for each format. So you can see that for cigarillos, and this there's a central tendency around 10% of cigars were consumed by under 21s, we estimate. For traditional cigars, it was closer to 6%. For filtered cigars, sort of was closer to 2%. By contrast, for cigarettes, the number is about 1.8%. And the most recent data are consumed by under 21s. So this is higher than for cigarettes, is what I guess we could take away. So running sort of a very simple but also complicated Kai-Wen Santa Ana difference and differences model that handles two-way fixed effects in the proper manner as prescribed by recent literature. We find using an event study and then sort of an effect study, so which means basically we looked at whether or not there were pre-trend differences in places that had tobacco 21 versus not, and in sales, and then we compared them to how sales changed after tobacco 21. We find pretty consistently that there is not significant systematic differences pre-tobacco 21, but after tobacco 21, sales of all three formats of cigars decreased. Filtered cigars, surprisingly, sort of the most, where there was a 13% drop in sales. For cigarillos, we saw a 10% drop, and traditional cigars, an 8% drop. This is sort of within expectations, but in that cigarillos have a larger effect size than traditional cigars. It's a little weird that filtered cigars are higher, but this is a very basic model, and I think what we're going to do is we're going to improve on this model by controlling for lots of additional covariates, and we're going to hopefully see this effect size shrink, because
Alex, you have about 2.5 minutes. Thank you.
Yes, wonderful. So yeah, this is a bit of a large effect size, but we'd like to decrease that with additional controls, because this doesn't control for lots of things that we think would affect sales. So yeah, cigarillos. So under 21 cigar consumption share seems to be greater than cigarette consumption share, meaning this is a bigger. Under 20, young people are a bigger part of the cigar market to tobacco companies than it was for cigarettes. Cigarillos appear to be the favorite format, and I think tobacco 21 likely decreased cigar sales, but we need to get a more realistic effect size, because I think this is skewed too high, being that it's larger than the under 21 consumption share. And so we want to use more traditional difference in difference models, leveraging differential under 21 shares and policy details, getting into the purchase, use, and possession details. And we want to add more appropriate controls to these models to understand whether unemployment, COVID lockdown, movement effects, price, and smoking bans, and marijuana consumption laws. Anyway, I think I'll leave 1 minute left on my time.
Great. Thank you, Alex. Nice talk. Folks, if you have questions, please do type them into chat. We'll address them during the Q&A session. And we'll move on to the second speaker, who is Dr. Ray Fu from University of Toronto. She'll be talking about automating the detection of American adolescents at risk of e-cigarette dependence using machine learning. Let's see. Okay, Dr. Fu is a postdoctoral fellow in evaluative clinical sciences at Sunnybrook Research Institute at the University of Toronto in Canada. She's also a postdoctoral researcher with the Center for Addiction and Mental Health, where she studies e-cigarette use and addiction among youth and young adults. As a health services researcher, Ray has passion for developing and creatively applying statistical methodology, including machine learning, to analyze real-world data. Substantively, she has delved into many fields of application by being the primary statistician on the team. Her overarching goal is to produce theory-driven, interpretable, and reproducible findings that can advance healthcare and health policy at the local and federal level. Dr. Fu, whenever you're ready, you can begin your presentation.
thank you so much. Hi, everyone. My name is Ray. Join you from Toronto, Canada. Thanks so much for having me. I'm very excited to share results of our pilot project, automating the detection of American adolescents at risk of e-cigarette dependence using machine learning with you today. So first and foremost, thank you very much, University of Michigan and all funders for supporting this work. So let's get started. Our project highlights machine learning as a technique to study youth vaping addiction. Specifically, we demonstrated the use of random forest, which is aptly named, as you will see. It's a forest because the model is basically comprised of many individual decision trees. These trees are constructed in a way that they are as random and as diverse, as different with each other as possible. So when we pull them together to act as a decision committee by using the majority voting of these trees as our final prediction, it is going to be accurate and robust. So this mechanism is known as the wisdom of the crowds or risk diversification, as seen in financing, portfolio development, investment. So in this project, we applied random forests on data from University of Southern California's Happiness and Health Study to predict the risk of becoming a frequent vapor over a course of 6 months, which we define to be the use of nicotine-containing vaping on 20 in the last 30 days. So the population is a group of LA high school seniors who are ever vapors at baseline. So beyond the construction of this black box random forest model, we were equally interested in deriving policy relevant findings from our final model. You know, the kind of results that non-machine learning epidemiology or public health study usually provides. So this includes identifying the most important individual predictors of youth becoming a frequent vapor in 6 months and characterize intersectionality. In other words, to find two-way interaction effects formed by socio-demographic variables that can help us to pinpoint youth that may be at high risk of becoming a frequent vapor. So let's look at some results. So we examined 131 potential predictors, and our final random forest model picked these 10 to be the most important individual contributors to 6-month frequent vaping. So unsurprisingly, some of the most important variables are about nicotine. So we have high past 30-day nicotine concentration in vape, the use of nicotine at all in their vape, and perceived nicotine dependence assessed by the Hooked on Vaping checklist. We also have items describing vaping behaviors and preferences. So for example, more daily vaping sessions, more numbers of puffs, and use of cannabis in vape. We also have expectations and willingness to vape and use a traditional combustible cigarette. And finally, there are 2 socio-demographic variables that made this list. So we have high perceived level of discrimination measured by the EDDS, which is the everyday discrimination scale. And we also have increased percentage of students who are reduced cost recipients at the participant school. So now I want to highlight our results and intersectionality, which I think is probably the most interesting findings from this analysis. So we have 9 socio-demographic variables in our data set, meaning that if we pair them like 1-to-1 together, we have 36 potential two-way interaction effects. So our final model found the 2 most prominent two-way interaction effects to be both related to age. So the most important interaction is age interacted with perceived discrimination, again, the EDDS, everyday discrimination scale. And the second one is age interacted with participants' race and ethnicity. So I'm going to highlight the first one, the age interacted with discrimination here. But if you're interested in our other results, please check out our publication of this analysis on nicotine and tobacco research. So when we look at the age discrimination interaction, we found a distinct, what we call hotspot. So it's this yellow area on this 2D diagram that we believe might represent a high-risk youth subgroup. So these are the students who are relatively young, because remember, we're talking about high school seniors here. So the age band is not that wide. But there are students who are kind of younger than their classmates. So these are students who are relatively young, about 17 and a half years of age, who reported high levels of discrimination. So our final model suggests that this subgroup of high school seniors are at particular high risk of becoming frequent vapers over a short period of time, which is 6 months. So this finding becomes even more apparent and prominent if we plot the 3D version of the same diagram. We just add an axis to depict the actual predicted probability of 6-month frequent vaping. So as you can see, at each age, we see the risk of becoming a frequent vapor in 6 months grows with a higher level of discrimination. But this risk really plateaus in younger students reporting high perceived discrimination, the red circle area here. So we believe our results might have some policy implications. So first, there's no doubt that nicotine plays a major role in youth frequent vaping. So any policy efforts that aims to curb youth vaping needs to focus on nicotine. And second, we believe there are vulnerable youth subgroups. So although these findings are definitely need to be more formally and statistically verified, because this machine learning analysis only represents a very descriptive, exploratory type of analysis. And finally, we believe machine learning may represent a valuable technique to develop this kind of surveillance tool that could be implemented by school counselors or by regional public health officials to help monitor youth vaping progression. We did not achieve automation in this project, although automating it is in our project name. So we're still working on that. Our final goal is to really establish an almost autonomous analytical pipeline that can absorb or feed itself with new survey data and kind of automatically refines its model structure and parameters and splits out predictive results that we are looking for. And also we implemented random forest in this analysis, which is kind of like a very common but basic supervised machine learning technique. There are state-of-the-art, far more sophisticated algorithms out there that can help us achieve automation while achieving even higher predictive performance. So I want to end my talk with lots of thanks to the T-Core program. The experience has been so rewarding, and I feel very lucky to have such generous support to do the kind of research I'm passionate about. So thank you very much, and I welcome any questions in a Q&A session.
Excellent. Thank you, Ray. Very interesting study and interesting results. Thank you for sharing. We'll move on to the next speaker. Our next speaker is Dr. Iris Shao. She'll be talking about the impact of individual decision-making and social network structures on anti-tobacco program effectiveness and disparities in adolescent tobacco use behavior. Dr. Shao is currently a postdoctoral research scientist at the University of California, San Francisco. She completed her PhD in epidemiology from Emory University, Rawlings School of Public Health in 2022. Her research focuses on the effectiveness evaluation of complex behavioral intervention strategies targeting modifiable health behaviors and substance use among adolescents. In particular, she's interested in bringing together socio-psychological theories and empirical research methods using system science approaches. Dr. Shao, when you're ready, please begin your talk.
Sorry, I was muted. And thanks, Ritesh, for the introduction. And everyone, thanks for coming today to the talk. So I'll be talking about the impact of individual decision-making and social network on youth tobacco prevention campaign effectiveness. So to begin with, youth tobacco product use is often driven by multi-level factors, as we know, and among those, and then the following are the three key drivers. And the first is the product feature itself. for example, the flavor or the design of the product. And on an individual level, individuals' perception of the tobacco product largely affects one's decision to actually pursue the tobacco product initiation or cessation. And lastly, social influence such as peer pressure, social norm, have a significant impact on the tobacco products use, especially among the teenagers and adolescents. So the education aspect of FDA's youth tobacco prevention plan actually focuses on addressing these specific aspects. But the evaluation of the effectiveness of this type of educational preventive plans, such as the real cost campaign, is really challenging, especially given the multi-level factor interactions and also the impact of social influence on the youth tobacco product use. So this project actually aims to understand how does individual decision-making and social influence collectively affect the long-term effectiveness of youth tobacco prevention campaign. And we conducted several agent-based computational experiments to actually address the following two questions. And the first is, how does population social network structure affect the effectiveness of youth tobacco prevention campaign? And then the second, given the initial prevalence of tobacco product users in the population and social network structure, what type of campaign information would be effective in reducing the prevalence of tobacco product use in the long run? So here is some conceptual map of like what the model will look like. So in this particular model, we actually decided to initialize a network of agents with agent attributes of tobacco product use, and as well as an inherent opinion towards the tobacco product use. So at each time step of the simulation, all agents will change its opinion based on those of its network connections and updates its behavior. To identify the role of individual decision-making on the population level behavioral dynamics, we adapted the framework of the DeGroot model of the belief for agents behavior updating function. So that is an opinion dynamics model. So the opinion dynamics model of belief has been widely applied in different types of research for information transmission, game theory, and social learning. Which makes this model particularly good for the study for behaviors such as youth tobacco product use, because the social norm and social learning are the two key components of behavior formation for this particular behavior. So to assess how social network topological characteristics actually affect the outcome of a simulation, we'll then vary key network features, including the clustering coefficient and average path length, which is a measure that actually captures the efficiency of information transmission within the social network. So to operationalize the implementation of youth tobacco prevention campaign, we decided to alter an agent's attribute, which is an opinion individual's inertia, to actually adopt the behavioral change by altering the probability distribution of the parameter that represents individual's inertia for behavioral change, as we can see here. And then this particular parameter, omega, represents the individual's inertia to actually change the behavior. So without access to this particular campaign information, they'll follow a beta distribution of 3-3, and to operationalize the implementation of a campaign, we decided to alter the probability distribution of this parameter to beta following the 2-5 beta distribution. So there are several key model assumptions for this particular model. First, all agents have complete information on direct networks connections information regarding access to campaign information. And the second, agent will recognize the normative behavior based on the initial prevalence of tobacco product user within the social network. And then lastly, the targeted campaign carries more weight than social influence on agents' behavioral choice. So those are the key model assumptions. Comparing graph A to C, we can see that shorter average length, path length is actually more beneficial for campaign effectiveness in reduction of prevalence of tobacco product user in the population, which is actually consistent with existing theories on the effectiveness of campaigns given shorter average path lengths, social networks. And however, comparing graph B to D, we found something really interesting, that the effect of altering individual inertia for behavioral change was able to outweigh the impact of network topological characteristics, which really highlighted the importance of individual decision-making in outcomes of tobacco prevention campaign. So to conclude, there are the two key findings from this particular project. And the first, average path length rather than levels of clustering of a social network is actually a key determinant of campaign effectiveness among youth. And then the second, increased individual self-appraisal through tailored campaign message can actually be very effective in the long run, even in the presence of a social network with longer average path lengths. For example, the type of network that's rather scattered or a community that's rather scattered geographically. So lastly, I want to thank all the collaborators for their contribution and also the support from the grant and the organizations. Thank you.
Thank you, Iris. Excellent talk. Again, please, if you have any questions to the speakers, type them in the chat. I see there are a number of questions already posted, but we'll address these questions during the Q&A session after the next speaker. The next speaker is Dr. Kai-Wen Cheng. She'll be talking about cross-state border nicotine vaping product purchase, early evidence from state emergency sales restrictions in 2019. Dr. Cheng is an assistant professor in the Department of Health Administration at the Governors State University. Her expertise is in health economics and policy analysis, specifically within the tobacco control field. Her research has focused on analyzing the impacts of various tobacco control policies, including the impact of taxation, clean indoor air laws, and cigarette smoking and related outcomes among various populations. Recently, she has been investigating the impact of state and local level indoor vaping restrictions, sales restrictions on vaping products, as well as other potential regulatory actions on the use of nicotine vaping products. Dr. Cheng serves as a co-investigator on several grants sponsored by the NIH and the Canadian Institute of Health Research. She has published articles in leading journals and has participated in scientific conferences at the national and international level. Dr. Cheng, whenever you're ready, please start your talk.
Great. Thank you. Thanks a lot for the introduction and the opportunity for me to share some findings from the project. My name is Kai-Wen Cheng, assistant professor at Governors State University. Today, I am presenting a single paper which aims to identify the potential cross-state border MVP purchase to avoid the state-level MVP sales restriction using 2019 Nielsen data. So this paper is one of the products of my pilot grant funded by Castor. I would like to acknowledge my co-authors, Dr. Alex Liber and Dr. David Levy. They provided useful insights and very critical comments to improve this paper. Some background information, flavors in MVPs have demonstrated a powerful appeal to continue to explain the widespread use of MVPs products. Recently, several states and local jurisdictions have implemented non-tobacco flavor bans in MVPs. Studies using retail sales data as well as retailer inspections data indicated a good compliance with flavor sale restrictions from major retail outlets. However, studies use survey data show the mixed findings. The survey studies indicated that most users could still readily continue buying and using flavored MVPs in various ways, either through online sources, stores in surrounding or neighboring jurisdictions which allow to sell flavored products, or any other informal social sources. So in response to the 2019 EVALI outbreak and concerns regarding high levels of youth MVP use, several states issued a series of regulatory responses that attempted to control the MVP market. This included an emergency order and ban on the sale of non-tobacco flavored or all MVPs. Massachusetts, Rhode Island, and Washington issued flavored or all MVP sales ban, and the ban lasted between 3 to 4 months in 2019. Other states such as Michigan, Oregon, New York, and New Jersey issued flavored MVP bans in 2019. However, orders were blocked at the court level, but later on in 2020, New York and New Jersey implemented a permanent ban. Our study focuses on MVP sales ban in Massachusetts, Rhode Island, and Washington in 2019. We identified and quantified the potential cross-border shopping activities from states where flavored MVPs were prohibited to states where flavored MVPs were allowed to be sold. We hypothesized that the border counties surrounding the states of Massachusetts, Rhode Island, and Washington will experience an influx of cross-border purchase due to the geographic proximity. We use Nielsen scanner data from Kilt Center. Nielsen works with a constant panel of retailers, including grocery, drug, mass merchandisers, and convenience stores in the United States. The participating retailers passively reported MVP sales volumes in a weekly basis, as well as the product characteristics such as product type, flavors, and the number of items contained per package for each unique product code. Nielsen data also released the state and county identifiers for retailers' location. Therefore, we will be able to identify the sales happening in the border versus non-border counties. Our sample included all neighboring states which share the common border with state with MVP sales restrictions. Our study sample include Massachusetts, neighboring states, including Connecticut, New York, New Hampshire, Rhode Island, and Vermont. Rhode Island's neighboring states, Connecticut, and Washington's neighboring state, Oregon. These neighboring states permitted all MVP sales during the study period in 2019, except for Rhode Island. Within each neighboring states, we further identify the border counties. That is, the counties which share the border directly with the state with MVP sales restrictions, and all other counties within the neighboring state are treated as non-border counties. So this slide shows this slide shows for each Massachusetts neighboring state the pre-ban and post-ban difference in MVP sales volumes by flavor type in border versus non-border counties. So as you see on the slide, in Connecticut, New York, and Vermont, the average weekly sales decrease among non-border counties after the ban. The results were presented in the blue bars. However, the average weekly sales increase in the border counties after the ban. The results were presented in the orange bars for all flavor types. In New Hampshire and Rhode Island, the border areas saw larger increases or smaller decreases in sales volumes than the non-border counties after the ban. After Rhode Island's ban, Connecticut presented that its bordering counties have either a greater amount increase or a smaller amount decrease in sales volumes than the non-border counties. After Washington flavor ban, Oregon, its neighboring state Oregon, presented that its bordering counties either have an increase in sales volumes or a decrease in the smaller amount than the non-border counties.
Kai-Wen, you have about 3 minutes.
Yeah, thanks. We also applied a difference in difference approach using border counties as the treatment group and non-border counties as the control group. difference in difference regression results indicated that after the ban, there is a significant increase in sales in all flavor type in border counties compared to the non-border counties. The increase in sales volumes in border counties is all significant across all three settings and all flavor types. This indicates there is a significant cross-border influx of sales, and the sales do vary by flavor type and state. Conclusion, our study identified a significant cross-state border MVP purchase in response to MVP sale restrictions in 2019. Results are consistent in all three settings of Massachusetts, Rhode Island, and Washington. The cross-border influx of sales do vary by flavor type and state. The cross-border shopping comprises about 10% on average of MVP sales in Massachusetts, Rhode Island, and Washington. This indicates that around 10% of the sales shifted from states with sales restrictions to states without sales restrictions. We suggest appropriate caution should be factored in this cross-border effect when evaluating any future potential MVP sales restriction. In terms of the future study plan, several states and local jurisdictions implemented permanent ban on flavor MVP and menthol cigarettes in 2020. The first most project is to extend our current study and add more states and 2020 or more recent sales data to compare and contrast cross-border shopping with respect to different ban and different settings. Thank you. That's all I have.
Thank you, Kai-Wen. Excellent talk. We appreciate all of you for your talks. We have a number of questions from the audience, so I will ask them in the order that they were asked of you. And also, I guess I'll go one speaker at a time so you don't monopolize a specific speaker. So let's start with Alex. Alex, Kara Kiesling. Kara, if you want to chime in, you certainly can, but I'm just going to read your comment and question. Could you please discuss how the product types are categorized? I was surprised to see traditional cigars as popular as they were.
Yeah, I think what Kara is getting at is an expectation that traditional cigars are premium cigars or unflavored, large, what we might call stogies or something like that, that are not associated very much with young people. What our data found was that, so what we did was we assigned a categorization for every single kind of cigar as either a blunt, a cigarillo, or a little filtered cigar. The filtered cigar was just a binary thing about whether or not there was a filter on it, and cigarillo versus large cigar is usually a matter of marketing, but in general, a larger cigar is marketed as a blunt or a large cigar, and a cigarillo is tagged otherwise, and it's smaller than a large cigar. The reason that young people use 6% of large cigars is that I think there's a variety of flavors of them. They can still be very cheap, costing under $1 per unit. I think they maintain some of the similar attraction that cigarillos do, just in a slightly larger format.
Great, thank you, Alex. This is a question for Ray. Ray, do you think the top 10 predictors are stable across many runs in your study?
That's an excellent question. And we did run a sensitivity analysis to address this issue because, unstable results are something that people complain about a lot in explanatory machine learning. So in our case, we did find that this set of particular 10 predictors, they do remain as the top predictors. But the method we used in that particular sensitivity analysis was not very sophisticated. There is a more rigorous and systematic way to kind of quantify the uncertainties around the ranking and the importance of this analysis. You can generate 95% bootstrapped confidence interval. So I have seen people do that. And I think for our next analysis, we might implement that method.
Thank you, Ray. And by the way, that question was from Thuile. This is a question for Iris. Dr. Mendez asked, what are the parameters of the beta distribution? What is the significance of those parameters in the context of your research?
Yeah, so the beta distribution in terms of like there are two beta distributions, and the one was following a distribution of alpha equals to 3 and beta also equals to 3, which has a density curve surrounding about like 50% on both left and the right hand side. And to actually operationalize, when people actually have access to the campaign, they may be more likely to actually alter their behaviors and more open because of the campaign information. So I decided to actually change the beta distribution to follow a parameter of alpha equals to 2 and beta equals to 5. So that basically is a way where we can actually operationalize how the campaign actually affects individuals' opinions, and which in turn actually affect the ultimate effectiveness of this particular type of campaign. Yeah, so that's
great, Iris. Thank you. I have a question for Kai-Wen. I was curious to see that the non-border county sales rates seem to go down after the ban in the neighboring states in your analysis. Could you comment on that finding? Because that seems a bit counterintuitive to me.
Yes. Right, it's a great question. Within the neighboring counties, neighboring states, the non-border counties also face the decrease of the sales. I think the reason is we are using the 2019 data. So during 2019, the Valley outbreak, the concerns on the health concerns on using nicotine vaping products really play a role explaining the downtrend to the products sales. And it is consistent across the board in the United States. If you present the national level data, the sales is going down, but it's especially after the Valley outbreak, the middle year of 2019.
Great, thank you, Kai-Wen. The next question is for Ray. Mona Isakbakesh has asked this question. Can you talk more about the data that were used in this analysis?
Yeah, absolutely. So the data used in this analysis was from the happiness and health study. So basically what happened is that in 2013, 4,100 high school ninth graders from 10 public high schools of LA area were recruited and follow up every 6 months. So in this analysis, we only used the wave 7 and wave 8 data from that large happiness and health study. So wave 7 occurred in fall 2016. So that's when the students started their senior year. So the fall semester of 2016. And wave 8 was 6 months later. So they're in their spring semester in 2017. So we restricted the cohort to be ever vapers at wave 7. So those who had some experience with vaping at the wave 7 survey. And it will also require the students to be successfully follow up 6 months later in order to observe their frequent vaping status. So these exclusions gave us 1,281 students in the final cohort. And because our outcome is 6 month frequent vaping, actually only 3% of them reported to be frequent vapers in 6 months. So 40 out of the 1,281 students in our cohort had a not positive outcome, but they were frequent vapers.
Great, thank you, Ray. A couple of more questions for you related to that last one. Was the sample from LA public and private schools?
Just public school.
Just public schools. And how did you get those arrows in your feature importance plot related to the top 10?
Yeah, that's another great question. So really, the variable importance analysis is a two-step analysis. You rank the importance of each variable, but from the ranking alone, there's no information about the direction of the marginal effect at all. So what we did, I think these results are included in the supplementary appendix of this paper. We also produced a one-way partial dependence plot. So we have to kind of visualize to eye the direction of that effect. So that's how we got the arrow from the ranking. So the ranking itself does not give you the directionality of those effect at all.
Great. Okay, if there are more questions, please feel free to type them in the chat or raise your hand and we'll call upon you. I do have a couple of questions for a few of the speakers. Alex, in your work, you said that you'll be adding some covariates in the analysis. Could you talk a little bit about what type of covariates you are considering?
Yeah, so I really want to account for the COVID outbreak. I want to look at, in particular, movement data that is provided by Google and Apple that get into whether or not people were leaving their houses. And during those periods of time, I found elsewhere that is a pretty decent predictor of sales in a positive sense, that more movement meant more sales, less movement meant less. I want to account for economic conditions. I want to head in price. I want to potentially, I also want to work on marijuana legalization rules, because that's fairly tied in with sales of certain cigarettes, with sales of, especially not cigarettes, but cigars. I also am interested in adding weather controls and a few other things like that. But the model I presented in the Kai-Wen Santa Ana design can't vary over time. And so it doesn't work so well for these sort of variables I just listed. And so it needs to use more of a traditional difference in difference setup.
Great. Thank you, Alex. I also had a question for Iris. I was curious on how individual psychology played into your model. I think you mentioned it, but I don't know if you accounted for any measures of intention to use, for example, or other psychological factors at the individual level, and how that may be related to exposure to the campaign.
Yeah, definitely. I think so. First of all, I think this is a relatively more abstract model, and then so we didn't really have empirical data that's incorporated into this particular model. So it's more of a conceptual model, and so I think that's a good next step in a sense, because right now the model, the piece of individual decision making was basically operationalized through this particular model parameter called this individual's inertia to change, right? And in addition, the baseline model, the reference model, is actually collaborated based on how much the people actually converge. So we find that initial prevalence, we collaborate that particular prevalence based on that assumption that adolescents are more inclined to actually conform. But then there's also, so that was actually embedded in terms of the model setup. And but I think there's one piece that's really important that's not really in this particular model is the incentive in terms of especially when exposure to a certain kind of tobacco product like cigarettes, right? And so I think that part will be incorporated in the future work, I would say. And then, so we didn't really do that here because of the complexity of the models, and we want to really piece out the social network effect and also the individual decision-making piece together. So because of that level of complexity, we didn't really incorporate more of that here. So yeah.
Great. Well, I want to ask one question to each of the speakers, and we'll just go in turn in the order of presenters. The purpose of the pilot funding was to, of course, support your career development and provide pilot data for future research in this area. So I just want you all, each of you, to just talk for maybe a minute about how this pilot research funding has supported your work moving forward, and where do you see this work going as next steps in terms of maybe larger research projects or new avenues of research? Alex?
So the pilot funding was essential in purchasing Nielsen sales data, which has underpinned at least 4 different kinds of projects, even beyond the pilot, and is the basis of my first R proposal to the NIH, which was about seasonality and weather and cigarette sales. And it's proved to provide lots of great preliminary data on so many fronts. So it will support my next NIHR proposal, and it's proved to be a really great stepping off point for purchasing data held in my name, and that has been really very helpful to have that kind of control.
Great, thanks, Alex. Ray?
Okay, thank you. So I appreciate this grant so much because I'm not, I don't consider myself to be a tobacco researcher. I'm doing my postdoc right now, and my postdoc research is not related to tobacco at all. So this is really my side gig. So I feel extremely fortunate to have such generous support. So this grant is what makes all my tobacco research possible. So I have things I can do outside of my postdoc research. I have additional publications. So I have always been very passionate about methodology. So right now about using machine learning in public health research, and particularly to use interpretable machine learning, because I don't want people to always think machine learning as a black box. Yes, most of the models, they are black box, but you can kind of derive interpretable findings from those black boxes. So I think my goal for conducting this line of research is really to convince people that machine learning analysis in tobacco research is, first of all, doable. It's feasible, it's publishable, and we can have findings that are easy to understand. We can explain to even non-statisticians. And so also my goal is really to provide like a recipe book for how to conduct a similar supervised machine learning analysis using survey data. Include all of my codes are publicly available as well. So I wish all of the resources will be helpful for future researchers.
Thank you, Ray. Wonderful. Iris.
Yeah, so it has been a really great journey, and the mentors from the T course and then the Castor program has been really, really helpful. And Dr. David Mendes have been really, really helpful throughout crafting throughout the whole entire project. And I felt that I also was able to really get to know what other aspects of the research is through these type of presentations and sessions. So I felt like this is a really great stepping stone, I would say, in the sense of bridging what I wanted to do and then what the future steps are, given that I started the project during my doctoral studies and then now I'm in a postdoc phase. And then I think this is a great transition phase where, wrapping up this project and then thinking about what the next steps are. So yeah, I'm really grateful. So thanks.
Thank you, Iris. And Kai-Wen.
Hi, yes, echo, very grateful to this funding opportunity. And as I'm coming from the, teaching organizations, so, this research resource, the fund is very useful, very helpful for me to continue working on the tobacco control research. I think I really like this Castor fund and this institution because it's a lot of information, and I keep receiving the emails, the webinars, all the talks. so it really helped me to keep connected to all the scholars in these areas. I really appreciate this networking opportunity. So I get to know Alex, I get to know Dr. Levy, and I got all the opportunity to continue working on papers with these great scholars. The fund, well, it's very useful because I use the fund to purchase Nielsen data, which is very, very expensive. I don't know how if I can do it without this fund. So I will continue doing research, and I wanted to write an art grant, art proposal. Perhaps I will start with the R15 because again, I'm working in the teaching institution, but so that really, I wanted to emphasize that, this resource is really, really helpful. Thank you.
Thank you, Kai-Wen, and thank you to each of the speakers. We appreciate your work and your time today.